CoderX here. In the last screencast, we set up a ClojureScript project, implemented a tic-tac-toe game, and published it online. Today, I want to show you how to work with a larger code base. We are going to convert our tic-tac-toe game into Othello, focusing on our workflow along the way. Othello is played on an 8x8 board with black and white discs. Each player places their discs in such a way as to capture the opponent's discs. Before we get coding, let's add testing feedback to our workflow. Don't worry, this won't be the boring style of testing you may be expecting, but it will take some setup to get going. First, add a dependency to our project.clj. DevCards is a library that showcases our components in various states. Copy the dev build section to create a DevCards build. Give it a different output directory so that the compiled files do not collide with other builds. Create a devcards.html file. Copy and paste the contents from the devcards README on GitHub. Start the new build we configured by typing lane figwheel devcards. Open localhost 3449/devcards.html. Seeing this page indicates that everything is working so far. In the core.cljs source file, add devcards to the namespace required. Refer the devcard macro. Now define a card with some text in it. The text can contain markdown. You can create titles and even format code. Refer devtest from devcards instead of test. See how our existing tests are now rendered into the page? Failing tests are coloured red. Instead of devcard, we will be using a more specific version, devcard-rg, which renders reagent components. We can define a card that shows a single piece of the board in a given state. Now we can isolate a single component to work on, instead of having to observe the entire application. We need a little more space here. Let's show our existing pieces and adjust the sizing. Okay, let's make some discs. We'll use blue instead of white for now, so that we can see the disc on a white background. We need to pass the coordinates to place them in the right location. Now we need a green background. Let's copy the existing blank piece, but make it green. And put the blank pieces behind our discs. That looks about right. Let's parameterize the blank component so that it takes the background color. We'll add an argument, but keep a default of grey if only 2 parameters are passed. Does it work if we pass red? Yeah, great. Let's make a card with a complete board. We don't need the title and button, so let's extract just the board. We'll change our convention slightly so that blank cells on the board are represented with a space. Then we can use a B for black disk and W for white disk. Update the render cases to default to a blank. The top left 9 positions are currently being initialized to B, because that was our tic-tac-toe starting condition. An Othello game starts with 4 pieces in the center in a diagonal configuration. The objective in Othello is to capture the opponent's discs by surrounding them. Here are the valid moves white can make in response to my move. Let's make a function to create a new Othello board. Now we will add another card to show the tic-tac-toe game. We need to update new tic-tac-toe game to use space instead of B. Notice that we now have two cards that show the same component in two different states. Adding cards and tests reduces our time spent clicking through the application while developing. Our blank cells don't do anything when clicked because they are modifying the global app state. We'll make them update the state passed instead. There is quite a bit of logic in this click handler. Let's extract that into a function. We'll need to pass a game atom through so that it can be modified. Checking the console for errors reveals that we forgot to pass an atom to our original card. We can use an empty map atom for those, as they don't need to respond to clicks. Our game atom needs a status because we prevented further moves after a win or a draw. Great, we can now click on the tic-tac-toe board and see the game progress. When we click on the Othello board, we are still using tic-tac-toe rules. It is time to implement the Othello rules. Let's start with detecting which cells' positions are valid moves and placing a disc instead of a nought. To preserve the tic-tac-toe rules, we need to separate logic paths that dispatch on the game type. Multi-methods are a good way to express this. You can think of multi-methods as case statements as functions. Def multi declares a name and the dispatch function. Def method declares a function to call for a dispatch value. Def multi needs to have the same signature as the methods. To start with, let's constrain the Othello can-move function to cells that are adjacent to a white disk. To dispatch by type, we need to give our games a type. Let's convert our new board function into a new game function, returning a map containing the game type, status, and board. Oh no, something went wrong. Uncaught error. 4 is not iSequable. Expand the stack trace by clicking the triangle at the start of the error message. Scan down the stack trace to the 4th row. Tic-tac-toe score available Q mark means in the namespace tic-tac-toe.core in the function available. At core.cljs rel:96 is the file name and line number. :96 tells us the problem is on line 96 of our core.cljs source file. The line above indicates that the problem occurred when calling getIn from the ClojureScript core namespace. Ah yes, getIn is expecting a vector containing I and j. Fixed. Player moves are limited now, but we still need to apply the same restrictions to the computer's moves. Let's rearrange a little so that we can call the same function from computer move. Put the board size inside the game and the background color. After these changes, the board size is not coming through to the game board. Aha! Game board takes an atom, So we need to dereference the atom to pull out the value we are interested in. But the computer is still not making moves. Let's print out what CanMove is doing. That all looks fine. Aha, we should be updating the game board here. We can make computer move more generic. Convert CanMove to return the game that would result from the move. Now, computer move is just the first successful result of CanMove when examining cells in a shuffled order. The computer is now placing white disks when we place a black disk. CanMove needs to be parameterized to behave differently depending upon who is making the move. The movement rule for Othello is more than adjacency. An Othello move is one that captures opponent disks between your move and one of your existing disks. Captured disks are flipped over and converted to your colour. To check for a valid move, we check for capture lines in every direction. A capture line is a sequence of the opponent's disks that is terminated with one of your disks. Let's write a test to see if this definition is correct. Given a board, space WWWB, placing a B at 00 should capture the 3W disks. Capture should return the coordinates 10, 20, 30. Given a board BW space WB, placing a B at 20 should capture the 2W disks on either side. Capture should return the coordinates 10, 30. We need to pass the game to our computer move test. Now we need the next game state to contain the results of flipping all the captured disks. Looks like I missed the terminating disk requirement. Let's add a failing test to capture that. Given a board, space WW space, placing a B at 00 should not return any capture coordinates. Capture line needs to collect a sequence of potential flips, but only return them when we encounter a terminating disk. Great, the move rules are in place now. If we ignore the win condition, it looks very much like Othello. Let's rearrange win to be game specific. Let's convert it to a multi-method on game type. In Othello, the player with the most pieces at the end of the game wins. Players must make a capturing move if possible, or pass. We can use the frequencies function to discover the count of space, W and B, in the board. Apply concat flattens the board from a 2x2 matrix into a one-dimensional sequence. If there are no remaining spaces, the player is a winner if they have more disks than the opponent. In a 2x2 game board, BBW is a win condition for black. Now that we have several tests, it is inconvenient to scroll through the page to view them. Let's get some output in the console to alert us on failures. In our project.clj, in the dev cards build under Figwell, add an on.jsLoad hook. Add the test directory to source paths and create a source file, run.cljs, under test/tic-tac-toe. Run will call ClojureScript's run all tests function. We'll also define a method to print out success or fail when the test's complete. Now we can see a summary of the tests in the browser console whenever we change code. In Othello, it is possible to reach a configuration where neither player can move, but not all cells are taken yet. Let's extract an available moves function so we can use it in both the computer move and win condition. Even though we extracted it, our current win code is much higher up in the file, so we will need to rearrange our functions to get the order of declarations correct. This is a symptom of a larger issue. There is a lot of code in core.cljs now. Let's think about how to split up the code into more coherent namespaces. Clearly, we have Tic-Tac-Toe specific code and Othello specific code. Can move and win will go in there. And we might create in the future some other game implementations. Our core namespace should be kept pretty small. Core will be focused on connecting a game state with the desired logic and a view. We'll need a central definition on the logic of a game. In which we can declare the multi-methods which will be implemented by the more specific namespaces. It will contain the code that is common across games. We have a bunch of component drawing code which we can put in a view namespace. Tic-Tac-Toe, Othello, and other implementations will depend on game, as they need the def multi to connect methods to. Core will depend on game and view and the implementations of new game. View won't need to depend on anything because it will just be rendering data. Okay, let's move these functions to the appropriate namespaces. By printing out the game in the console, we can see victory is reached. Let's check if Tic-Tac-Toe is still working. I think we're all set. Let's play our game. So far, we have been running the dev cards build. We want to switch over to viewing the dev build. In your terminal, interrupt the current build by pressing Ctrl+C. Now run both builds simultaneously by typing lane figwheel dev devcards. Navigate to localhost :3449 to see the dev build. We only want to mount the main game when viewing the dev build, so let's put that inside a conditional. Let's play our game. This is interesting. I cannot move, but the computer has already moved. In this situation, the computer should move again in the last remaining cell. We can achieve this by making check game status recurse while there is no player move available. Let's add a test to make sure our logic works. Here is a small 3x3 board where there are 2 more computer moves and no player moves. Let's play some more games. I think the victory message should be on a different line from the buttons. A strong strategy when playing Othello is to focus on positions instead of how many discs you can flip. The most advantageous positions in Othello are the corners, which can never be lost and allow you to recapture long lines in many directions. Next best are the sides, for the same reason. When starting a game, it is better to capture fewer discs. This limits your opponent's options and allows you to force your way into a side or corner. Once you can establish the safety of a side and corner, you will have many opportunities to reclaim the central discs. Time to publish our board game. Our project source file are now Core, Game, Othello, Tic-Tac-Toe, and View. And we added a devcards.html file to the resources directory. I created a new repository for the combined games so that there is a separate repository for each video. But you don't need to. I'll rename my output file to othello.js to differentiate it from my previous project. Let's check that the minified build still works. Interrupt the current build with Ctrl+C and type lane cljs build once min. Open index.html if you want to check it locally. Commit and push to the GH pages branch. Navigate to username.github.io/project to see your page. Let's review. We converted our original game into 2 games. The Othello namespace contains our game-specific rules for Othello. An Othello game has a green background, the player is B and the computer is W. The board has 4 discs in a diagonal configuration at the centre. Valid moves capture 1 or more lines of discs of the other player. A draw occurs if there are no available moves to the player or computer. We can shorten this test by using a new board instead of repeating the values. A win occurs when neither player can move and one has more discs. The core namespace has the game selection view and attaches the rendering. The view namespace has the blank, circle, cross, discs, and game board component. The game namespace declares the multi-methods that will dispatch by game type, and some logic functions which are common between games. The Tic-Tac-Toe namespace contains implementations specific to Tic-Tac-Toe. We have a minified build which is published on GitHub pages, a dev build, and a dev cards build. Dev cards presents cards and tests that occur in our namespaces so that we can see what our components will look like in predefined states. We added an on.js load hook to report a test summary to the console while developing. If you have any questions, please drop a comment. Until next time, keep coding.